How do wheels help us? A wheel rolls, and things that roll are easy to move. It's much harder to slide something than to roll it. As the barrel slides over the rough cement, the boys have to use a lot of strength to move it. The barrel is rubbing against the sidewalk. At the same time, the sidewalk is rubbing against the barrel, slowing it down. We say it slows down because of friction. Stop sliding and you reduce the friction. Now there's almost no sliding. So the boys are working against very little friction. That's why a rolling object is easier to move. But what does this have to do with wheels? You don't need wheels for a barrel. No, but what if you want to move one of the boys? Here's a better way. Or is it? That's right. You need more barrels to move a longer distance. Of course, you'd never really use barrels this way. But you might use metal rollers, which work much the same way as barrels. Rollers or barrels are not so good for moving boys. Wheels are better. Each wheel turns on an axle. Between the turning wheel and the axle, there is some friction. There's not as much friction between this wheel and axle. The roller skate wheel turns easily because it's on ball bearings. You can see the bearings when we remove part of the wheel. See? Tiny metal balls between the wheel and axle. With these bearings, the wheel rolls very easily around the axle. Ball bearings are also used on a bicycle wheel. The wagon doesn't have ball bearings, but there's still less friction than if the wagon were dragged over the ground. Notice that each wheel is free to turn by itself. The axle doesn't turn with it. But sometimes wheels are fastened to an axle. Most train wheels are made this way. Both wheels and axle turn together. These toy wheels are fastened to the axle in the same way. See? If you turn one wheel, the axle and the other wheel turn also. This doesn't work so well when you try to make the wheels follow a circle. The outside wheel skids because it isn't free to turn a greater amount than the inside wheel. Now we fix the wheels so that each one can turn about the axle separately. This is a better arrangement for following a circle. Now the outside wheel can move a greater amount than the inside wheel, and it doesn't slide. Remember that the wheels on the wagon are also free to turn separately. The wagon can turn around in a small space. Tractors must also turn in very small circles. So the wheels are made so they can turn different amounts. What about the wheels on a car? Yes, each one is free to turn a different amount. Can you think of other uses for a wheel? Suppose we change the wheel a little by cutting out notches. Now, it's a special kind of wheel, a gear. The notches, or teeth of the gears they're called, can fit between the teeth of another gear. So if you turn one, you turn the other. They turn at the same speed because they're the same size. By making one gear smaller than the other, with fewer teeth, we can make one gear turn faster than the other. How can we be sure? Mark both gears to give each a starting line. Now, watch the line on the small gear as we turn the large one. See? The small one turns several times in the time it takes the large one to turn once. Gears of different sizes can help us in many ways. A hand drill works with gears. The hand turns a large gear. The large gear drives a small gear connected to the drill. The drill turns several times each time the hand goes around once. So it's possible to turn the drill very fast. When you turn the pedals of a bicycle, you're turning another kind of wheel, something like a gear. A sprocket wheel. The sprockets, or teeth of this wheel, fit between the links of a chain. The chain moves when you turn the wheel. The sprocket wheel with the pedals is much larger than a second sprocket wheel attached to the bicycle wheel. So each time your feet go around once, the rear wheel turns several times. That's one of the reasons you can go so fast on a bike. A sewing machine makes use of wheels driven by a belt instead of by a chain. This wheel has raised edges to keep the belt from sliding off. There's a lot of friction between the wheel and the belt because the belt presses tightly against the wheel. When the belt is moved, the wheels move along with it. She keeps her fingers away when the motor is on. Here's a wheel used in another way. Recognize the round handle of a faucet? With the wheel off, try turning it on using just your fingers. It's pretty hard to do. It's much easier with a wheel. With the wheel, you can apply more force. This boy is applying force to a wheel on this cart. The steering wheel. The steering wheel is fastened to a long post. Connected to the post at the bottom are two rods. Turning the post moves the rods. The other ends of the rods are connected to the front wheels, controlling their direction. In this way, the steering wheel can be used to control the direction of the cart. You've seen some of the ways in which wheels help us. But have you seen all the ways? Of course not. There are many, many other uses for wheels. Just look around you.